Great morning, afternoon, evening, my mini mathematicians, and salutations. Thanks for being here today. We're going to start on page 17. I'm on page 17. Are you on page 17? Excellent. Let's track the title and read it together. 7.1b lesson, areas of irregular shapes. So we've been talking about areas of triangles and trapezoids and parallelograms, and today we're going to be looking at some irregular shapes, which are compound shapes of circles and rectangles and triangles and lots of fun shapes. So activity 1, please track with me as I read the directions. Area using dot paper. This is all dot paper. The following shapes have been drawn on square dot paper. The distance between each dot represents 1 unit. So from here to there is 1 unit. Use what you have learned about area to find the areas of each shape, A through L. Use pi as 3.14 for an approximation. So you will need a calculator, and we will work through these. And I want to remind you that one of these little squares has a side length of 1 centimeter. However, the distance across a diagonal is not 1 centimeter. It's bigger. So let's take a look at A. How can we break up A and to find the area? Well, I see one really big rectangle. That's a 1, 2, 3, 4 by 1, 2, 3. So what's the area of this rectangle? 3 times 4, that's 12 square units. And I'm just going to put numbers here because it might get messy for units. And these little ones are a 1 and a 1. So the total area of figure A, I'm going to show my work down here, is 12 plus 1 is how I figured out, which is 14 units squared, or square units. I'm going to circle that for my answer. Another way you could have thought about A is finding the area of the large 2, 3, 4 by 1, 2, 3, 4 square, large square, and subtract this little rectangle, and you'll end up with the same answer. Let's do one more that has some funnier shapes in them. Let's take a look at shape C. Take a look at shape C. Shape C, I see half of a circle and another half a circle, and then this big rectangle. And this rectangle is a 1, 2, 3, 4, 5 by 2. 5 by 2 is 10. And then I have these circles, and the radius of the circle is 1 because the whole diameter is 2. And it's important that we look at the radius because the area of a circle is pi r squared. So if I'm figuring out the area for shape 3, I'm going to go down here and I'll have the area of the square plus 2 halves of a circle make a whole circle. So base times height plus pi r squared for area of a circle. And remember, we found the area of the rectangle to be a total of 10 because it was a 5 by 2. And your radius is 1. What's 1 squared? Oh, that's right, it's just 1. So 1 pi, which we're going to call 3.14 for an approximation. So our area of shape 3 is about 13.14 square units. And you can always write out the word square units if you wish, or you can use the exponent of 2 like we did here. Awesome. Why don't you take some time with your group? Let's pause the video for about 5 minutes while we work on these irregular shape areas. Try to do as many as you can in the next 5 minutes. Please pause the video for 5 minutes while we work on these shapes. Awesome. Let's take a look at how we did in going over these shapes. Shape B, I broke this up into 2 different rectangles. And remember, maybe you broke up the shape into a different parts of the areas, but when we add them together, we're going to get the same area. And this is a 2 by 4, which has an area in 8, and this is a 2 by 5, which was a 10. And so when we add those two rectangles together, 8 plus 10, that's right, 18 square units for shape B. Awesome. See, we already did. Let's take a look at D. I decided to break up D into a rectangle that's a 2 by 4 and these little triangles. And remember, the area of a triangle is base times height divided by 2. Area of a triangle is base times height divided by 2. Here, the base of this triangle is 2, and the height, which meets the base at a right angle, is 1. Or we could drop, do you remember what that word's called that describes the height? That's not a size, like an airplane. That's right, drop an altitude to find the height. So 2 for the base, 1 times the height divided by 2, ends up being 2 divided by 2, which is 1. So each one of these triangles is a 1. And this rectangle was a 2 by 4, so that's an 8. So for shape D, I found my area to be 12 square units. Maybe you broke up that shape into something a little different. Let's take a look at shape F. Shape F, I broke this into a 4 by 2 rectangle. Remember, an area of a rectangle is base times height, which 4 times 2 is 8. And I broke it into this triangle where here is my base of my triangle, which is 4, and the height, or my altitude, is 2. So to find the area of this triangle, I know that the area of a triangle is base times height divided by 2, 4 times 2 divided by 2, which ends up just being 4. 8 divided by 2 is 4. So the area of shape F ends up being 8 plus 4. And 8 plus 4 is 12 square units. And it's interesting because as I'm doing this now with you, I'm actually breaking up the shape sometimes differently than I did the first time, which is uploaded on your Google Classroom in my website. So taking a look, it looks like I skipped E. Oh, here it is, that little tiny shape. This is called a kite, as in Mary Poppins, let's go fly a kite. So I look at this kite, and what we could do is we could see this as two different triangles. I have this triangle that has a base of 2 and a height of 1. So I have this triangle has a base of 2 and a height or an altitude of 1. 1/2 base times height here. 2 times 1 divided by 2 ends up being 1. So the area of this little triangle is 1. And then I have the area of this larger triangle, which also has a base of 2, but in this case has a height or an altitude of 2. So now base times height, 2 times 2 divided by 2, 4 divided by 2 is 2. So we have an area of 1 and an area of 2 for a total, remember total means to sum, area of 3. That's right, E has an area of 3 square units. Excellent. How have you and your group been doing? Let's take a look at G. G is a little trickier. If I take a look at G, the way I first started doing it when I saw it the first time was I tried to break up my funny trapezoid, but I noticed that I had these weird lengths that weren't quite on vertices, and I didn't know what they were. So from there I noticed I could take the large rectangle around them and subtract this trapezoid, this triangle, and this triangle, and then I'd just be left with my funny trapezoid in the middle. So that's what we're going to do. And maybe you got a little stuck on this one too. And that's okay. Always remember to do your best and try to persevere. So what we're going to do is, like I said, and if you need to use your opposite page, that's fine for G. I needed to as well. When I'm looking at shape G, I'm going to take the big rectangle, and I'm going to subtract the trapezoid, I'm also going to subtract this triangle, and that triangle. Minus a triangle, minus triangle. Always try to draw them the same way so I can label them correctly. And minus this longer triangle. Okay, let's fill in what these dimensions were so we can figure this out. This rectangle is a 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7. So the area of this rectangle, rectangles are base times height, 28 units squared. So we have 28, and we're going to subtract this trapezoid. This part from here to here is 1, and this is 1, 2, 3, 4. And remember, since these are the two sides that are parallel to each other, they're that's right, they're our bases. And these are called our legs, which we're not too worried about. But here, because we make a right angle, this leg is also that's right, it's our height. And that's right here, 1, 2. Perfect. And we need to find the area of this. And the area of any trapezoid is base 1 plus base 2 divided by 2 times your height. So we have 1 plus 4 divided by 2 times your height, which is 2. Order of operations, we need to add first, or do what's in parentheses. 1 plus 4 is 5. 5 divided by 2 times 2. Think about this 2 as 2 over 1, and they cancel out. And I'm just left with 5. So the area of this shape is 5, our trapezoid. Let's take a look at our other 3 rectangles that we need to subtract from our rectangle to figure out the area of this funny trapezoid. So let's see, this has a base of 1 and a height of 1, 2, 3, 4. Let's look at our other triangle. This has a base of 1 and a height of 1, 2, 3. And our long skinny triangle on the bottom has a base of 1 and a height of 1, 2, 3, 4, 5, 6. Oh, it goes all the way to the end, 7. And remember, your base and your height always meet at a 90-degree angle. Okay, so let's take a look. Base and height of 4. Well, a triangle is base times height divided by 2. So we have 1 times 4 divided by 2. 1 times 4 is 4, divided by 2 is 2. So we have an area of 2 here. So again, we're going to end up with 28. We're going to subtract 5, and we're going to subtract 2. Let's look at our next triangle. Base times height divided by 2, area of a triangle. We always want to go for our formula first. And here we have 1 times 3 divided by 2. So we end up with 3 halves, or if you like to think about it as decimals, 1.5. Minus 1.5. Now, the next one, our next triangle is a 1 by 7. Base times height divided by 2. 1 times 7 divided by 2. 7 halves, which if you like to think about that as a decimal, half of 8 is 4, so this is 3.5. So we can subtract all of these from 28, or you can think about 28 minus and add all of these together because it's the total that oops, this is a 3. Almost made a mistake. That we're subtracting, the total that we're subtracting. So we need our parentheses there for some order of operations. Okay, you finish up this area and the video is going to end, and we will start the next video to go over those last couple shapes. Thanks!